As we start, and I'm letting you see what I look like a little bit here, and this is the 21st of May. We're getting ready for Memorial Day weekend on our summer course here, but we're still working ahead. A couple of questions as we start. Now, looking at this, this is a term that's now a factor. What would we call this particular term? A monomial. And these are two terms. What would we call that? A binomial. So this is a case of multiplying a monomial by a binomial, and we just distribute and end up with a product now as a result of this factor times this factor. Now, this is the distribution principle that we're following. What would we call it if we went from this back to that, where we take out a common factor of 3x? Well, we'd call this second part factoring. And in this section, we're multiplying, and then later in chapter 5, we'll be factoring. So a little background. Now, as we look at the material given here, they're going to show us a number of different special products. The difference of two squares, the square of a binomial, the square of a binomial, the binomial differences. So as we look at this first one and copy it down, I don't know if you can see that in a sense it's the same terms in each binomial, but one is negative and one is positive. This is often described as the product, since you're going to multiply these, of the sums and difference of the same terms. Well, this relationship, these are called conjugates. One of my favorite words, so write it down. Now, an interesting thing happens when we multiply conjugates, and I'm going to use the FOIL that we'll be illustrating here. When I multiply the first, I get x squared. When I multiply my outers, which is the second letter of the word FOIL, I get a positive 7x. When I do the inners, I get a negative 7x. And when I do my last, I get a negative 49. So this gives me an interesting result that the two middle terms cancel out, and I'm left with x squared minus 49, which is called the difference of perfect squares. Now, interestingly, if you see later in chapter 5, you have the difference of perfect squares, it will factor into its conjugates. Now, another type is this one, and we'll write it again. This is a binomial that we're going to square. Now, another way to write it is just write it twice as indicated by the exponent. Now, if we FOIL that, my first term, 64x squared, my outers, a positive 16x, my inners, a positive 16x, and my last, a plus 4. Now, notice we have like terms in the middle here. So when we group like terms, we get 64x squared plus 32x plus 4. Now, someone clever has developed a shortcut way of doing this, where you take your first term and square it, multiply these two terms together and double it, which is what this is, and then square this term. Now, when we do that, the resulting product is called a perfect square trinomial. Now, if you recognize that you have a perfect square trinomial, eventually you might factor it into this, knowing it came from a binomial that was squared, or having it spread out this way. Again, multiplying is the easier way of doing things. All right, we're going to give you a chance for some hands-on now. Now, there's a number of ways to do multiplication of binomials, and the more traditional way is this. You take the first member, x, this one, and multiply it by the second binomial. Take the second term in your first binomial and multiply it by the second binomial. So when you do that, you get x squared plus 9x plus 7x plus 63. Again, getting like terms in the middle, which gives us a plus 16x, and just collecting everything. Now, again, I want to have a little practice of the FOIL, so let's do that together. Outers, x squared. I'm sorry, first, now the outers, plus 9x. Inners, plus 7x. And last, plus 63. Now notice we're getting the exact same results. FOIL is just another way of doing it. And x squared plus 16x plus 63. All right, for number 4, you could do it this way, but I prefer doing it the long way, we call it, just that we line things up in their like term columns. So we're just writing this trinomial and then the binomial underneath it. And we can put a 1 there to help us with our calculations. And basically you're going to go 1 times this row, which just repeats that row. And then negative 1x by each, putting your like terms in their proper column, and let's see what you get. And take a moment, check your signs, and this is what is the outcome. All right, let's move it up. Now they do want us to use the FOIL here, so give it a shot and see what you get. So verifying the first, 2x times 4x, 8x squared, your outers, 6x, inners, 12x, last, 9. Like terms in the middle should end up with something like this. Now jumping down to number 6, notice we're using the FOIL for these two, and then we're going to multiply everything by an x. Now notice these are conjugates. So when you do your FOIL, you're going to get the difference of perfect squares in here, multiplied by the x, and let's see what you get. So something like this, Squaring the 5's 25, adding exponents x to the 6th. A negative times a positive gives you a negative 36, and then you just distribute the x, and this is what you get. Again, if you have a question, be sure you're asking. Now, we'll give you these last two to work on your own. And basically, again, I'd use the vertical method to write these out. You're going to multiply the 1 times this, and the 3x by this, the x squared by this, putting them in their like term columns. And here, this is just distribution, collecting like terms. We did one like this at the upper part of this. All right, give you some time. Okay, I ran into some writing here, but hopefully you can follow. Again, the nice thing about this, I think, is you're lining terms up in their like term columns. I've put ones here to help in the calculation. And then we've done this before. Now keep in mind, multiplication is so much easier than factoring, where they may give us this trinomial in the next chapter, and we have to factor it. We could possibly do it from this method, but again, we'll work on that as we move into chapter 5. All right, we'll wrap this up.